Today, we're going to talk about how to solve for missing angles in a variety of different ways using the angle relationship that you can identify.
All right, so when we take a look, the first thing we're going to do is determine what the angle relationship is. And since we know that these angles are directly across from each other and we have two straight lines intersecting, we know that these are vertical angles. What do we know about vertical angles? We know that vertical angles are equivalent. So what we might want to do first is realize if we know that this is 63 degrees, we actually know that this value is also 63 degrees. What else do we know? We know that there's a y value here, and very often we'll be asked to find what is the y value. So if we know that these vertical angles are equivalent, we can set these two expressions equal to each other. So by doing this, we're simply literally setting them equal to each other with an equal sign. And then we're just going to solve for y. Now here we know that y equals 9, and perhaps that's the end, and that's all that we're going to do. But if we wanted to double check to make sure that we did and were able to see if these were equivalent, we could take that 9 and plug it back in. And here you can see that we got 63 degrees, which makes sense because we know that vertical angles are equivalent. Now coming on to the next screen, we notice that these are also vertical angles. First thing we'll do to determine what is the angle relationship. This is a vertical angle. We know vertical angles are equivalent. So we're going to set these two expressions equal to each other. So x plus 16 and 4x minus 5. Then we're simply going to solve for the equation. There's lots of different ways that you can solve for this, so just choose the most efficient method for yourself. So we knew that x equals 7, but we're not done yet because we probably want to figure out what the actual angle measurement is. So we can go in and plug it into either expression. I'll plug it into both just so that you can take a look. I get 25 degrees on this side. I do not get 25 degrees. I get 23. Math. Good thing to double check my work. And I get 23 degrees on that side, which makes sense because they're vertical angles and they should be equivalent. All right, taking a look at this next guy, same idea as always. We are going to take a look and say, what type of angle relationship is that? I see that those two angles together make 90 degrees. I know that those are complementary angles. Since they equal 90 degrees together, that means I can add both angles together to equal 90. So if you notice here, I'll take this 35 degrees and I'll add it to the 4x plus 7. And I'll know that that equals the 90. Now you might already be thinking in your head, I know a quicker way to do this. I'm going to show you this way, and then we'll take a look and see if there's another way that I could have done this since I'm actually given an angle measurement here. So I'm going to go ahead and solve. Now, if all it asked me to do was to find x, I could go ahead and say the answer is 12. However, remember, x is not the angle measurement. The angle measurement is when I take that 12 and plug it back in. So I get that that's 55 degrees, this angle guy right here. And you probably are already noticing, hey, we could have done that a little bit different. So perhaps you notice that this angle right here is 35 degrees. I know this whole angle here is 90 degrees. So I actually could have done in this case 90, take away 35, and gotten 55 degrees. Doesn't always work out that way so nicely, but you could have done it in this case. All right. right, last guy here. First thing we're going to start noticing is what type of angle relationship are we seeing? I'm noticing straight away that these two angles form a straight line. What do I know about straight lines? I know that straight lines or supplementary angles equal 180 degrees when put together. So I know that this expression and this expression, if I add them together, should equal 180 degrees. So how do I go about doing that? I take 2x plus 3, I add it to x minus 6, and I set it equivalent to 180. Then I start simplifying my left side of the equation. I end up getting 183. I divide both sides by 3, and I end up getting 61. Now, again, remember, this is the error that a lot of people make. They stop right here. They say the angle is 61 degrees. It is not. Your x value is 61 degrees. At this point, you will need to go in and you can plug it into either one of them or both of them to figure out what each angle measurement is. So first off, I'm going to do x minus 6. So that's really 61 minus 6, which I end up getting 55 degrees. So I understand that this angle right here is 55 degrees. Now I can go through 2x plus 3. That's really going to be 2 times 61 plus 3, which is 122 plus 3, which is 125 degrees. There we go. That's this angle. If I add 125 degrees plus 55 degrees together, I do get 180. Another way to go about solving this is if I would have solved for one side, I could have then subtracted it from 180 to determine what the other side was. So remember, in solving all of these equations, or these missing angles, the very first thing that you need to do is really determine what type of angle relationship you have going on with your problem. Hope this helps.